Morning, Mervyn.
Morning, Andy.
How are you? You okay?
Yes, I'm well, thank you.
Good. Can you see me okay? Is my video working?
I can see you, yes.
Okay, perfect. Good. Okay, good.
Yeah,
good.
people are starting to come on, so I'm just going to give it till 10.
Okay, perfect.
Yeah, I can't see you now. You've just turned your camera off, yes?
Yeah, just checking.
That's fine.
Working. Okay, great.
Yeah.
I'll put myself on mute for now then, Mervyn, and yeah, speak to you soon.
Yeah, thanks, Andy.
Cheers.
So, good morning, everybody, and thank you very much for attending today. This is our first event of Net Zero Week, and I must say we're very excited to be partnering with this new week. It's obviously very topical, a very important week of events for the Net Zero Week, and I'd love to say thank you very much to Sean Coles for how much effort and work he's put into organising this week, and Esther are very proud and pleased to be partnering with many other organisations for the week. This is our first event of this week. We've got half a dozen events on this week, and obviously all details of the events are on the Net Zero Week website. A little bit about myself, Mervyn Pilley. I'm the Director of the Energy Services and Technology Association. As I've already said, we're pleased to be partnering for this week. For those of you who don't know, we're an energy efficiency trade association in the UK, have established for about 35 years and have a wide range of members offering energy efficiency services across a number of sectors and sizes of business. And yes, I just really also just briefly wanted to reiterate how we think that energy efficiency is a critical part of net zero. It should be really the start point for everyone's net zero journey. And obviously that's one of the critical reasons why we're very happy to be supporting this week. So yes, without further ado, I'd like to introduce Andy Mackenzie of Schneider, who is our first presenter of our first event. And Andy, I'll let you do your own introductions if that's all right with you. You're very. Oh, can I just quickly, before you go over to you, what I would ask is if you can put your, if you do have any questions while Andy's presenting, if you could put them into the chat facility, please. Obviously, if you could stay muted. If I do need you to perhaps ask your own question, I'll let you unmute, but otherwise I'll try and handle the questions as they're coming through chat. So yeah, I'll just keep an eye on the chat. But other than that, Andy, over to you, please.
Thanks, Mervyn. Yes, hello everyone, good morning, and thank you, Mervyn, for the invitation today. It's always great to work with Esther. We're always looking forward to the discussions we can have working with you as a partner. And yes, good morning or good afternoon, depending on where you are in the world, to everyone that's joined us on this morning's session. I'm Andy Mackenzie. I'm the microgrid lead for Schneider Electric in the UK and Ireland. 20 years experience background in renewable energy, smart building technologies and infrastructure. Microgrid is a phrase that people are going to be hearing increasingly. If you aren't already involved in this sector, then you'll certainly be hearing more of it in the coming years. It's a hugely growing market right now, but it also means a lot of different things to different people. And as a key part of a net zero strategy, it's important to understand the different strategies, the different options that are available to you in terms of the technologies that are out there in the market. So I'll just share my screen now, and hopefully you should all be able to see my presentation. Is that okay?
Yeah, that's great, Andy. Thanks.
Great stuff, thanks. Okay, right. So what we're going to be looking at today is a global overview of microgrid. And if you do have questions, as Mervyn said, please pop them into the chat, and we'll try and have a Q&A session at the end today as well, if required. So just a brief overview. Many of you may have heard of Schneider Electric previously, and it's important to emphasize that although there are parts of Schneider that make products and install those products around electrical infrastructure, I actually sit within a part of the business called Energy and Sustainability Services, where one of our main goals is to work with organizations, with partners, with customers to help them achieve their sustainability targets, or indeed work with them to even develop and set those targets to begin with, because net zero is a terminology and a phrase that will be discussed a lot in conversations. It's gone from the point of just being something that we talked about in terms of environmental sustainability. People are now talking about sustainability in terms of business practices, financial sustainability, carbon sustainability, but also sustainability looking at things specifically around technologies like electric vehicle uptake. So there's a lot of different conversations being had, and it's important to know that whether you're an organization who's got a very advanced carbon management strategy, or whether or not you're just starting out on the road to developing these ideas, we're going to cover some things off today that may help you understand what it is you need to do and how it is you need to benchmark yourself, and also how you can incorporate different technologies going forwards around the topic of microgrid. So you'll be pleased to know I'm not going to go through all of the bullet points on your screen right now, but that's just a quick overview of what the Energy and Sustainability Services team do. So the team that I sit in, these are some of the topics of conversation that we have with customers, because becoming net zero is a big challenge, whether you're a small to medium-sized business or a multinational organization. There are a lot of different factors you need to consider, and it's something you need to document, it's something you need to develop, and it's something you maybe need to lean on in terms of third parties giving you advice and guidance, or even just sharing best practice with other organizations that you work with. So let's move on to today's specific topic of conversation, which is part of our active energy management program, as we call it, which is a microgrid. And I'll explain in just a moment why we call it an active energy management strategy. So ultimately, the grid that we have had serving us for the last 100 years is changing significantly. So what we've seen historically is we've had a single line of transmission from large centralized generation through transmission and distribution down to the end user, whether that's commercial or retail or residential. Now, what we've got is a great model that's worked very well, and it serves our population as it's been growing. But what we've seen over the last few decades is very much a conversation around sustainability, climate change, carbon reduction. And we've seen the introduction of what we call distributed energy resources, or DERs, which is an acronym you'll see in the industry. Now, these DERs can be solar farms, they can be wind farms, they can even be localized on-site solar generation or wind turbines. The scale is there in terms of whether it's private use or whether it's contributing something to the grid. And what it's doing is it's starting this conversation, this discussion around bidirectional flow, so two-way flows of energy. That historic model of just large coal or gas-fired power stations or nuclear giving us our energy, that's changed. We've now got other assets out there in the field that are contributing to our grid structure. Now, on top of that, we live in a very smart and internet-enabled age. As I said earlier, we've got the rise of electric vehicles, whether that's at fleet or at residential scale. We've also got a lot of talk around battery storage systems as well, but we've also got smart assets, smart devices. If you think about your metering strategy, which may be very simple at the moment, but you may be looking at developing a more complex view to get a detailed look at your estate and your portfolio, or whether it's down to things like substations, transformers and switchgear, which are a key part of our infrastructure. They all have some sort of smart technology in them these days, and that can produce an awful lot of information. So sometimes even just understanding how you set out your roadmap to net zero can be a big challenge. You can almost feel like you're overwhelmed with data. So one of the key things to do early doors is look at how you can get two different types of views on that data. You can get dashboards that will give you a summary of what that data is doing, but you can also get automation as well, because for us, part of the microgrid world, part of the microgrid strategy is enabling automatic decisions to be made based on customer profiles, based on specific customer needs, but it's very heavily based on the fact that we have a lot of information being produced by devices and assets, very, very advanced ways of processing that information, and through a consultative approach, deploying a strategy through a microgrid that will give you your optimized site and help you on the road to net zero. And we'll go through those different stages of consultation and design throughout this session this morning. So the main bit here with a microgrid, the reason why we developed this solution, this strategy, is to try and give you one window of all of the different things that are happening on this screen right now. So if you think about your site, which may be a single site, or it may be a portfolio of buildings, you've got a lot of information. You've got your incoming electrical or gas supply. You've also got your on-site assets in terms of any cooling, heating, hot water production. You may have industrial process lines. You may have office blocks. You may have EV charging. All of these things produce information. Now, what you don't want is someone having to sit down and try and process all of that information in real time. It can be a daunting task. And also there are other variable factors that we'll look at in today's session that can affect and influence how you're going to be deploying your net zero strategy, including simple things like your tariff management strategy and things like weather forecasting as well. How can you get the best out of your renewable assets going forwards? So what we try to do is, in the same way that historically building management systems have been brought online to control our built environment, our workspace, in terms of making sure that simple things like heating and cooling systems aren't working at the same time, a building management system will optimize and develop an ongoing automated process of control and feedback that shows you that your building is being run optimally. So you've got something controlling the air changes, your space temperature, and also things like your hot water, and even sometimes your access to the building. A microgrid does the same thing, but for energy. So it's making sure that if you've got an opportunity to generate excess energy from your solar, for example, you can make a smart decision about whether you use that energy now, whether you sell it back to the grid, or whether you store it in a battery to either use later or sell to the grid at a later time. So what we're trying to do is bring back all of these different data streams into one simple window and automate the control strategy around these assets. It might sound a little bit complicated to start with, but hopefully as we go through today's session, you'll see how we can simplify this and enable a microgrid as part of your net zero strategy. So what does a microgrid look like? Well, first of all, you'll see a lot of different definitions out there in the marketplace, and those definitions vary depending on the technologies you're looking at and the application. For us, this is simply about creating a defined space or a geographical remit. It may be sites that are disparate all over the world, or it could just be one building on its own. As long as you have a defined target around your microgrid strategy to say, these are the loads that we're monitoring, this is the grid that we have a relationship with potentially, and these are the assets that we have on site to generate or control or store energy. It's about making sure that you have a defined structure and strategy around an interconnected group of what we call distributed energy resources. So this is just an example or an illustration of what a microgrid might look like. You might already have existing assets on your site or your multiple sites, such as solar photovoltaics. You may be looking at things like wind turbines. You might have backup generators or something called a combined heat and power unit, which takes a fuel source and turns it into heat and electricity. Or you might have something called a tri-generation unit, which can also cool. You might be looking at battery storage in the future, and you'll certainly, or most certainly, almost certainly have a utility connection of some sort, whether it's electrical or gas, and even water, although water is not included in our microgrid strategy discussion today. And what you'll have on your site is loads. This is illustrating a single load, but you may have multiple buildings, you may have a process line, you may have a particular type of technology, such as electric vehicles, that you want to monitor as a specific load. And what we're trying to build up here is a picture of the different assets available to us through our microgrid. You'll have your incoming utility supply, you'll likely have some backup generators, maybe some solar photovoltaics, and you'll certainly have loads of different assets or types of technology consuming that power. Essentially what we're doing with our microgrid is we're pulling back data, existing data from these assets and putting it into one place. So typically what we want to do is hardwire these assets in. We don't like to use wireless technology at this stage because of reliability and communication issues. So we like to hardwire in or use existing data collection services. So if, for example, you've got a metering system on site and that metering system is being collected and put into an analytics package, depending on the compatibility, we may be able to extract that information from your already existing metering system and pull that into our microgrid to say, this is our load data, this is what we're using. The same with the utility. Essentially, in terms of a physical footprint, our microgrid is just a panel on site. So it's already enhancing the existing assets. So if you ignore that sort of grey block in the middle that says controls, a lot of sites that we deal with already will either have these assets or we'll be talking about them for the future. All we're simply doing is putting a panel on site that can communicate with these different assets. And we use open protocols, so industry recognized open protocols such as Modbus or BACnet, KNX, LAN, etc. So it doesn't have to be Schneider assets that you're talking to. We're very well aware that a lot of the sites we work with and interface with will already have an existing third-party solar system, third-party building management system, and may have a third-party metering system. So we're very much about open communication and about pulling all of this data back into one place. And there are three types of microgrids. There's one that is permanently connected to your utility supply. There's one that is permanently off-grid, so running independent of the utility at all times. And there is a version of the site that can be islandable or islanded from a utility and run independently from the grid when it needs to. So that system is very good in areas where there's high problems with grid resilience. So parts of America and Africa, for example, where there's grid instability, it's useful to be able to bring a site back online if the grid does drop out at any stage. So essentially what we're looking at, as I said earlier, we're looking to create one window, one automated process for all of these different types of systems. Now, the reason why we're doing that is because what we want to do in any net zero strategy is make sure that our loads are optimized and as efficient as possible, that we're using the right types of utilities at the right time of day, and we'll come to that later, and that we're using our low to zero carbon technology wherever possible to ensure that we've minimized our carbon footprint. Now, getting to net zero might not necessarily happen quickly. This may be a strategy that you need to develop over 5 or 10, 15 years. You need to set realistic goals and look at your infrastructure, because first and foremost, whilst this looks like a great project, a great program with a microgrid and various different generating and storage assets, not every site is going to be ready for these straight away. You may have aging infrastructure. You may have problems with blackouts or power dips, and it's important to get those right before you start investing in any kind of significant changes to your strategy. So again, part of a net zero strategy is acknowledging where you are right now with your infrastructure, your metering strategy, for example, and making sure that energy efficiency is at a core part of what you do. There's no point investing in a significant level of microgrid technology if your efficiency program isn't up to date and you're wasting energy on your site. So although I've already mentioned the phrase microgrid quite a bit, and it's in the title of the presentation today, a lot of the clients and partner businesses that we work with talk about microgrid without even realizing it. So on the left-hand side, we have a long list of questions or topics of what our customers are actually trying to achieve, or we will ask these questions early doors in our discussion. So if a customer comes to us and says, we're trying to achieve net zero by 2030 or 2040, we'll go through a lot of these questions as per their relevance to understand where a customer is in terms of their site or their estate or their portfolio of buildings, and build up a picture of what it is they do day to day, how they do that currently, and how we can help transition them through energy efficiency, through infrastructure, and through renewable technology to get them to a net zero strategy. Now, in its simplest form, now this looks like a bit of a busy slide, but I can assure you that hopefully by the end of this, you will understand the benefits of a microgrid solution. So ultimately, as I said earlier, our microgrid is a panel that's hosted on site, and within that panel is a controller that has software. So for us, there are two very, very clear streams of how a microgrid is designed and developed and run. The first stage is to have a heavy sort of emphasis on understanding what is being achieved on site or what needs to be achieved going forward. So there's a lot of discussion early doors around what the microgrid needs to look like, what it needs to try and achieve. And the second bit is to have a modular software approach. So this is very much about software and optimizing what's already in place and what's being brought online later. So there's a real strong emphasis on clear discussions, but then also designing the right solution for the site. So every microgrid we work with is bespoke. It's designed for that site and that organization's needs or that individual company's needs. And what you can see here, although this slide does look a little bit busy, I'll talk you through it if we start at the bottom. So at the bottom here, we've got our connected assets. So on that schematic I showed you a moment ago, these might be examples of some of the types of technology that you may have or may be considering for your site going forward. So we've got battery storage, on-site renewables, here it's indicated as solar. You might have industrial loads or processes or energy loads. You might have things like electric vehicles, heating, ventilation, air conditioning or building management, and your utility. Now we can, as I say, tap into all of these assets and create a network of information. Now, if you're looking to run a site that can go independent from the grid, you will need a local power control system or power management system within your site. You don't want it hosted in the cloud, you want something hosted locally. So in case you ever do lose your broadband connection and you're running independently from the grid, you've got something hosted on your site that is controlling and maintaining your microgrid safely. Now for us, this is EcoStruxure Microgrid Operation. This is hosted on site in a controller, typically within the low voltage system, and it runs the network independently from the utility. Now, when you look at this particular platform, it's very much an engineering tool. It's not about having it on a flat screen in a reception area to show people what your network is doing. This is very much geared up to control the network safely and securely. But the majority of sites that we work with have what we call Microgrid Advisor or our cloud-hosted analytics level. Now, this produces graphics that are simple to understand, so you can have them on display in a reception area or talk about them in a board meeting, for example, and then you don't need to be an engineer to understand what these graphics are telling you. Now, this is where we start building up the real smart elements of optimization within the microgrid. So this is where all of the real benefits of this solution take place. So when we install a solution for microgrid, as I said, we typically commission a panel on site with a controller in it and a communication device to send information up into the cloud. We hardwire that panel to our local assets, and we would have built up already, before that panel is installed on site, a profile of how the customer or client wants that microgrid to work. So what are the priorities? And in this case, we're talking very much around net zero strategy, and that will be the theme throughout all of this conversation. So what we'll do is we'll have that panel installed, and from the first 4 to 6 weeks after commissioning, that
Hello, Andy.
Yes, sorry, Mervyn.
That's right. You've gone. We lost you there, I think.
Oh, okay. Yeah, I think there's a bit of a broadband connection, unfortunately, Mervyn. I'll try and switch my video.
Yeah, you're disappearing a bit, or you're
See
vanishing.
if that helps.
That might help. Yeah.
So what we've got here essentially is. Okay, great stuff. Thank you. Let me know, Mervyn, if there's another problem.
I will.
So what we tend to try and build up is a picture of the past, present, and future with our microgrid. And the future is the really important bit around a net zero strategy. So once we've commissioned our site, the first 4 to 6 weeks, our system is just learning and looking at trends around load profiles, on-site renewable assets, when and how the electric vehicles are used, etc. And it starts building up trends and profiles of what normal looks like on that site throughout a 24-hour process, 7 days a week. What we then do is we talk to our local panel. So our panel is scanning the network every minute. So we're pulling back a lot of data here, which is another reason why we have a dedicated network. And we're collating those in our local panel. And every 15 minutes, we're sending that data up into the cloud. What we then do is we cross-reference that against any historical loads or profile data that we might have for the system. And we can see, is our system behaving currently as we anticipate that it should? If the answer is yes, that's great. We can operate and optimize the system accordingly. And we'll have set parameters around things like demand charge limits from the grid, times when we want to perhaps potentially optimize our tariff, but primarily times when we want to maximize the reduction of our carbon footprint. So let's just say this is a site that has electric vehicles, some solar PV, a 24/7 profile with a low occupancy on the weekend and a small amount of battery storage. Our system will be collecting data all through the week on how the site is working and cross-referencing it against historical load profiles to understand what might be happening in the future. So typically, let's just say it's a Wednesday and it's a university site, and the site itself is trying to minimize the carbon footprint for the site during the day. There are things we can do, such as smart load shedding. We can optimize how many electric vehicles are being charged at any one time, but we can also put a strong emphasis on maximizing the usage of any on-site renewables. So if the sun is shining and you've got plenty of energy being generated by your solar PV, our system would have a zero export strategy during the week to ensure that as much power as possible is being taken from the solar and used locally to create this clean power. Now, you may start with a small system over time. As I said, net zero isn't achieved overnight. You might say, okay, for the first 5 years of our net zero strategy, we'd like to achieve a 40% reduction in carbon, 80% reduction in carbon emissions, and by year 15, we want to be net zero. Now, this can involve energy efficiency, it can involve investment programs and investment cycles in renewable energies. It can also potentially involve investment in enhanced efficiency technologies, such as building management systems, so getting more control of your built environment, more control of your automated and industrial processes, but also potentially even looking at battery storage as well. And one thing we haven't discussed yet is incoming grid supplies. You may already have a 100% renewable energy supply coming into your site, which is brilliant. And as long as you've got the right carbon credits for that, you can be deemed to be carbon neutral. But getting to net zero is another thing entirely. So that's talking about your site operating from a zero carbon emissions perspective directly. And there are some significant benefits to that over procurement of green power. The significant benefit being you have on-site generation of low to zero carbon technology that gives you control over your power. So if you're still using a 100% renewable energy supply from the grid, that's great. But should the grid drop down at any point or you have a blackout, you are stuck a little bit, to put it politely. What we're trying to do with Microgrid is enable resilience. We're in a very, very digitized and electrified society, and it's only going to move more in that direction. We see a lot of organizations moving away from on-site combustion of fossil fuels, and that's going to put more strain on the grid as we go forward. So a big part of a net zero strategy is actually the resilience that you can get from having on-site renewables where possible. Now, another thing we haven't discussed is that not every site will be able to have renewables installed, whether it's a a small footprint of land, or whether it's an absolutely landlocked building like a tower block in London, you're very, very limited with the scope of technologies that you can include in your site. But what we're seeing now with the rise of microgrids is where sites have a very, very small renewable footprint. Land is being bought outside of a site, somewhere else in the country, somewhere else in the county, somewhere else in the region, and renewables are being installed there. And so through a cloud-hosted application like Microgrid, you can have one site data being pulled through as your load. So that could be your tower block in London, but that could be balanced with your other site data, your site out in the countryside that has solar or wind, and you can show through the software the two sites balancing out in real world time. So that's net zero. You're achieving what you need to. Yes, there's an element of arguing that that's carbon neutrality, but those two sites are within your portfolio. You're contributing something to the grid, you're taking something from the grid, but not every site, we understand, has the luxury of a footprint of having the ability to have solar PV on site. So there are lots of different ways of looking at, through Microgrid, how you can embrace renewable technologies and really get the most out of it for your net zero strategy. So what we're doing with our site is we are, as I mentioned, pulling through historical data, whether it's our tower block, whether it's our university site, whether it's our industrial process. And let's just say we've got some solar, as I mentioned, EV and battery on site. We can look at data from third-party systems being pulled in, such as weather data, energy tariff data, any demand response requests, etc., and specific customer constraints to help optimize the site again for carbon zero strategies. So let's just say, for example, we're putting in a weather forecast that says in 2 days' time it's going to be particularly cloudy, and we're going to get only 50% of our normal return from our solar PV. What we'll try to do, particularly at a time like this during the year when we get long sunny days, is we might say, right, well, our site is 9 to 5. And instead of selling our excess PV power after 5 o'clock back to the grid, what we'll do is we'll store it in a battery on site. So we've stored some carbon zero power, and we can use that later on in the week to offset the fact that we'll have reduced generation.
Andy, we seem to have lost you. Hello, Andy. Andy, can you hear me? Hello, Andy. Andy. I do apologise, everyone. It would appear we've lost Andy. I'm just trying and get hold of him quickly to see if we can get him back online. Apologies for that. These things happen, obviously, but just a shame that it's happened on the very first event. So let me just see if I can just text him quickly to see if he's trying to try and get back on again. He clearly was having some problems earlier, so it might just be something that's coming back again. Right, I've just texted him, so apologies. Let's see if he responds quickly. If not, I'm not quite sure that he had much left of his presentation to do, but let's just see if we can get back on. I've got one question in the box at the moment. And I have just made observations that oh, Andy, are you there? Andy? No, he was on again and now he seems to have dropped off. Ah, here he comes.
Hi, Andy, can you hear me?
I can hear you now, yes.
Hi, can you hear me, Logan?
I can you hear me?
Yes, apologies.
I'll make you host again. Hang on a sec.
Thank you. Yeah, I do apologise. My broadband.
No, these things happen. These things happen. Don't worry. You said about we're in a very digital age. Unfortunately, the internet connections aren't clearly quite
Absolutely, yeah. Apologies.
there yet.
Everyone must be hosting webinars this morning, so
Probably, yeah.
Hopefully you didn't miss too much. Were we on this screen when my connection dropped?
Yes, I think that's the one you were on. Yeah.
Okay, perfect. Many thanks.
Possibly the one before, and I'm not quite sure. Just go back one. That's the one I think we were on. No, you've done that one. No, it's that one. I think
we've been through that one. Yeah.
Yeah.
Okay, brilliant. Okay, so hopefully you've got the summary of how that system works. Did you hear me explaining the solution there, Mervyn, for that one?
I believe we did, yes.
Yeah, okay, perfect, great stuff. So just to give you an overview, some of the key things that you need to consider when you're looking at a microgrid solution around the actual technology itself. First of all is the security. That's one of the key things. Obviously, anything cloud hosted, you need to have high levels of cybersecurity. Ours is hosted up to defense standards, so MOD, US Air Force, etc. We've worked with those particular types of providers, but you obviously want to ensure that your microgrid is cyber secure. This is very much about an open and scalable solution as well. As I mentioned earlier, net zero doesn't always happen overnight, and it may be a 5, 10 or 15-year strategy that you have. So something like a microgrid solution, which is software focused, can grow with your site. So you may start small. Your microgrid might simply be that you have some solar photovoltaics to subsidize your electric vehicle charging. Over time, you can then introduce other things like hydrogen fuel cells, battery cells, etc. And these can all be added into the software as you go forwards, because you're simply adapting the software strategy to enable you to move towards that net zero goal. The nice thing about the software as well is it runs 24/7. So when you're talking about a microgrid technology, you're talking about something that will run permanently. You don't have to have someone constantly monitoring your site. And as I mentioned, it's an optimized system. So it's not quite artificial intelligence, but it's what we call advanced algorithms. So it's always looking at how it can best optimize the site going forwards. Now, one of the key things when you're looking at any kind of net zero strategy is how you set and define your use cases for your site. The main use case that you need primarily will be self-consumption, so number 4 on this list. But that's not to say exclusively that microgrids only do net zero. They do other things as well. So if on your net zero journey, you need to look at potentially revenue generation. So if your site has a lower load profile at the weekend or at certain times of the week, you may want to sell power back to the grid to get carbon credits or financial revenue. So you can have your microgrid changing mode depending on what you want it to do. And not every site will need all of these, by the way. These are the different software modules you can have. Not every site will need them though. So primarily, as I said, for a net zero site, you'll be looking to maximize your self-consumption and potentially have a tariff management module of some sort as a revenue stream if you are looking to sell back to the grid. But one of the key things with any microgrid conversation or any net zero strategy is understanding very, very early doors how you want the system to work. Because we still have customers coming to us now saying that they're investing in a significant amount of solar, but at the very last minute, they've decided they want to look at battery storage and microgrid, but they don't really know why. So they haven't got a sizing for their battery solution. They don't know when they want the battery to be deployed. They don't know how they actually want the system to work. And that's, again, something that we can help with. Any consultative engineer out there will be able to look at load profiles and help a client understand how they can potentially build up a picture of microgrid success. So just to simplify things again, this is a very, very simple architecture. We've got our connected products. So as I said earlier, anything that's smart, that is out in the field, or that you're looking to upgrade, so things like smart metering, switchgear, substations, transformers, electric vehicle charging, whatever it might be, maximize that energy efficiency and that visibility. So if you are looking to upgrade your infrastructure, you may see that some products are a slightly lower price because they don't have some of the smart technology or monitoring capability built into them. Sometimes it may only be a few pounds difference, but make sure you go for the smart technology, because whatever you're investing in it now, you will save that in the future going forwards. Whereas if you go for the technology that isn't as smart, that doesn't have the high level of visibility and data capture, you may regret it later in terms of your visibility and your ability to capture data and information relating to your site. So make sure your connected products are smart, or that you've got a strategy around procuring smart energy infrastructure. In fact, we're even finding now that some of the smarter technology, simply because the materials being used in them are more renewable, recyclable, easily available. Some of the older technologies have less environmentally friendly products, can actually be a better value option to begin with. Then you need a place to capture your data. So some sort of local panel or system that will pull all of this data back into one place, and then that sends it up to your apps and analytics level. That's where, as I say, the magic happens, because you can look at what your site has been doing historically, what it's doing now, and how it may be performing in the future as well. So looking at how weather, things like outside air temperature, cloud cover, etc., can impact on your site, and also specific things around your EV load as well. So making sure that you're using your power from your solar PV or any other renewable assets to the maximum benefit. So if you've got a lot of vehicles plugging in, you don't want to be selling your power back to the grid at that time. For your net zero strategy, you want to be using and maximizing as much of your power on site as possible. And you need something smart to make that decision for you. And that's what a microgrid does. Just to give you an idea of some of the scalability, you can go down to an individual building level if you want to. And that's actually a great starting point, especially for energy intensive sites. Sometimes it can be really, really key to develop a proof of concept around your microgrid and your net zero strategy. This is a building over in America that wanted to be zero carbon and be independent from the grid. So this site can actually run if the local grid experiences a blackout. So there are two different drivers here. Firstly is the net zero and the off-grid preparedness. But also this site is in a nature reserve, so they wanted to demonstrate and show different types of renewable energy technology. Those all build up a part of a resilience package, a resilience program that people can see when they come and visit the nature reserve. They can actually see renewable energy technologies in place. And as you can see, this site has a consumption maximum demand of about 450 kilowatts. So it's a fairly smallish profile of a site. But then, as I mentioned earlier, microgrids aren't just about electrical power, they can be about thermal as well. So we can start looking at things like combined heat and power systems or tri-generation systems that do combined heating, power generation and cooling all at the same time. Now, this is a site where we were approached by Lidl, the international grocery chain, to develop a program for them based around a renewable energy strategy. So they wanted this site to be a super performer. And this site is actually 50% more efficient than the previous two industrial facilities that they'd had built. So this is a distribution center. And because of the microgrid software, because of the cutting edge technology they used, it actually only uses half the power of a standard distribution center. It's got renewable energy on site, so they wanted something that's built on 100% renewable energy. And this building is actually now overperforming to the point where they're selling some of their excess thermal energy to neighboring properties. So this is very much about planning your microgrid from early doors. Now, we know not every site is going to be a new build, but microgrid works really well on a retrofit site or a brownfield site as well to help you with your net zero strategy. You don't have to be building a new technology center, a new energy center to get to net zero. You can do that with existing sites, but you need to be very clear from day one what your loads are going to be, what the technologies are that you're using, and any kind of renewables that you're going to be incorporating into that system. This is what's called an energy as a service model. So although the graphic on the right-hand side looks a little busy, I'll talk you through the simplification of this. Essentially, this is a local authority that wanted to move towards a more sustainable and net zero strategy. So they started investing in solar. They then experienced some problems with power quality from the grid, and this is a critical power site that runs 24/7. It's an administration headquarters for fire, police, and ambulance services. So they had to ensure that they had power at all times, and they wanted to do that as sustainably as possible. So what we've got here is a site that had a very, very high net zero ambition, but unfortunately didn't have the capital to enable that. So ultimately what we did is we partnered with a company called Rec Solar, who make solar panels and install them, but they also installed CHP. So we partnered with them as the on-site generating technology partner. We partnered with a company called Duke Energy, who were the financer. So Duke Energy put up all of the finance to begin with. So they paid for the capex of the project that we designed with Rec Solar. Now, the nice thing about energy as a service is that it's over a set period of time. So in this case, 15 years. The lease agreement is then with the client. So the client is leasing these new assets back over a 15-year period from the financer. Now, within that package, they get a fixed price of electrical power. So they're experiencing less risk from volatility within the energy market. All of the maintenance and operation is outsourced as part of the contract. So essentially, the client has gone from having a poor carbon performing estate to a brand new estate with new infrastructure as well. So this isn't just about the on-site CHP and solar. This is about the infrastructure that was rebuilt as well to give them a super efficient and resilient site. Now, energy as a service is a model that you will see a lot more going forwards, where organizations want to de-risk their business, reduce their carbon footprint, reduce the pence per kilowatt hour, but also having that ability and the reliability of a stable infrastructure that means if the grid does go down, this site, for example, has an element of resiliency where it can keep running in the absence of an incoming utility. And at the upper end of the geographic scale, so we've been working with the island of Gibraltar for a couple of decades now to move them away from their traditional infrastructure of standalone diesel generators. So when Gibraltar was cut off from mainland Spain in terms of its power supply, Gibraltar literally became an island overnight in terms of its resilience and in terms of its on-site generation. We've been working with them to move away from disparate standalone diesel generators that caused a lot of issues with air quality, but also caused a lot of problems with power generation and reliability, to the point where they now have a smart, fast healing grid. Now, what we've done here is exactly what I mentioned earlier. We've taken a site that had problems with air quality, with poor performing older assets that were using fossil fuels, and we've worked with them to upgrade the infrastructure over time. So we've put in a cutting edge, state-of-the-art switchgear and generation system that means that they've now significantly reduced their carbon footprint. They've got more resiliency, reliability. And this is really the key part of understanding how a microgrid can benefit a net zero strategy as well. It's not just about the renewables you attach to the network. It really is about how the network operates and the visibility that you've got within it. And so going forwards, Gibraltar are now considering a lot more renewable energy technologies, etc. They've got much more visibility of how their system works and far fewer blackouts. And finally, the last sort of tongue twister for me, really, this is what utopia looks like going forwards, because we've often talked about microgrids and smart cities as well. These are microgrids within a microgrid. So this is a smart campus in France. Each of these buildings has its own microgrid strategy. So it is constantly being optimized by a microgrid system to reduce its carbon footprint. 20 is made up of different buildings that have different load profiles, that have different energy capabilities in terms of their generation. And so they actually share power between all these different buildings, depending on the loads of those buildings and what's being generated. Now that is a private network essentially, but they still have an overarching strategy that looks at how that site interacts with the grid when they buy and sell power from the grid, for example. So I've worked in the energy sector for a couple of decades now, and I know that people have been talking about smart cities and smart districts for some time. And it's a big thing to take on, to reduce that much power consumption to get you to a net zero city is a significant amount of work. But it can be done in pockets. If you start building up centres of excellence, business parks with microgrids, university sites, local authority buildings with microgrids, you start suddenly getting pockets of zero carbon over time. And that's how I believe we can enable smart cities and smart districts going forward with net zero strategies. It's about saying where are our energy intensive or where are our best energy saving opportunities? How do we deploy microgrid technologies to manage those, but also share power between different assets when it's available? So just to sum up, this is about ensuring that you've got the right architecture in place. In order to achieve net zero, you also need to have very, very realistic targets. Don't be too ambitious. Don't set yourself targets that you cannot achieve and that you feel let down by when you miss your first goal or your first window that you were aiming for. Be realistic and learn from what you're doing previously with your site. You're the experts when it comes to your own infrastructure. So you know what can be achieved and how your business needs to operate while you move towards a net zero strategy. So it's really, really important you have those early conversations with organizations like Schneider and Esther to understand where it is you need to go. This is also about reliability, as I mentioned. So a big plus from net zero strategies is that you increase the amount of reliability on your site. As you integrate more and more renewables on site and become more and more energy efficient, you increase your resilience as well. And analytics, this is about making sure that you have got analytics that you understand. We can be inundated with information and dashboards that tell us something or nothing. You want your dashboards to tell you what you need, but also that they feed into a microgrid as well. As I said, an automated microgrid platform can make your life very easy when it comes to a net zero strategy. So what we want to do is finally make sure that you have got engineered solutions. What you need to ensure when you're developing a net zero strategy is that your procurement strategy is correct as well. If you buy energy efficient projects in isolation, you won't get the maximum benefit, because you will get some benefit, but what you need is an overall solution around integration. So all we've seen today is about the integration of as many different assets as possible. If you go to a procurement exercise, for example, and buy an LED lighting product that can't be integrated into a smart grid system for communication protocol reasons, you're missing a bit of a trick. There's a lot of information out there in the market about open protocols, and lighting manufacturers, product manufacturers, they have huge amounts of data sheets, etc. they can give you with regards to integration of your systems. So just make sure that your solution is engineered, that when you're talking to someone about how you achieve net zero, make sure that early doors, when you're investing in something like LED lighting or a substation, that you get the right technology in there, maybe not for today, but for the future as you build your net zero strategy. And finally, just some quick simple steps of how to get a microgrid. First of all, look at your information that you've already got. If you haven't got your metering data to hand, start looking at how you could capture that, because the key bit of understanding any kind of net zero strategy is understanding where you are today. Look at the assets that you've got on site. What size are your generators or your solar PV? What finance models are you as a business prepared to accept or take on going forwards? Would you look at something like energy as a service? Then, as I say, assess what your site is doing. Metering data doesn't always tell you what is happening on site. There are lots of good organizations out there that Esther can put you in contact with, or you can work with Schneider to do this. We can help you understand what your metering is actually really telling you about your site and where your efficiency may be. Because as I say, one of the key things is understanding where's the opportunity for energy saving to begin with. Before we even talk about microgrid, how do we become more energy efficient? Then going forwards, once we've got a design for a microgrid off the back of our efficient systems, we can start to integrate over time, not necessarily overnight, the distributed energy resources and the appropriate infrastructure needed to enable those. And then finally, one of the key things is that it isn't a fit and forget. You've got to have continuous optimization, service and maintenance around these assets in order to achieve your net zero strategy. The technology won't do it on its own. It very much needs input, fine tuning as well. Once we've designed and commissioned the microgrid, our system is automatically optimizing itself. But some solutions and technologies out there in the market don't do that. They may need a bit of recommissioning or fine tuning. And that's when you need to talk to your product supplier or your maintenance team to ensure you've got all those assets optimized. So on that point, Mervyn, I'll hand back to you for any questions and answers. We've got you on mute at the minute, Mervyn.
Apologies, gosh, I should know about that by now, shouldn't I? A year and a half of Zoom. Yes, sorry, Andy, we've got three fairly chunky questions actually, or they look fairly chunky. I hopefully won't be too difficult to answer or too long answer for you. First question from Eyes on Chalk. Hi Andy, where does Schneider Electric view the application of DC power being adopted in residential and commercial markets? Are the current standards adequate for a wide uptake? If not, what should be looked at?
Yeah, so DC power is something that we're now starting to look at, but certainly on a large commercial scale. But yes, there are definitely benefits, particularly when you're talking about rapid DC chargers for electric vehicles, DC battery storage systems, and the fact that we just fix sense that is the route that we would head down. And there are companies out there in the residential market looking at this, but for Schneider Electric at the moment, we're still sort of dipping our toes in the water in elements of the residential market. We do work with partners, but for us, DC is still very much at a commercial scale. But it's a very, very exciting solution because there's a huge amount of benefits involved, and the efficiencies are there within the network. But we're happy to field any individual inquiries, Mervyn, if possible.
Okay. I mean, the question about the standards aspect of that, I wasn't sure whether that was a specific part of that. I mean, I don't know who would govern the standards of
that's also something we're working on, because the DC companies that we're working with at the minute have projects globally. We're looking at how they would interface into the UK and Ireland market. Okay. We've got established projects in the European Union at the moment, so we're just making sure those standards are where they need to be. So that's an active that's an activity that's on our to-do list at the moment.
Right. Okay, that's great. Thank you. Next question. Gosh, this one looks like a long question as well. Hi, Andy. This is from G. Rajavan, and apologies if I haven't pronounced your name properly there. Yeah, hi, Andy. Great presentation. Could you please clarify how the physical optimization of assets work with the commercial agreements, e.g. interface with contracting with NGC on ancillary services, fast frequency response and triad management?
Absolutely. Yeah, great question again. So what we do with our particular system, and again, I'm sure other product suppliers of Microgrid will do the same, because we use open protocols, we can interface with third-party aggregation or demand response requests, etc. You will have seen on the list of use cases that I had where I talked about self-consumption and tariff management. We've actually got software modules in there for fast frequency response and things like demand response. And again, we all know not every site will have those abilities in terms of the assets that are needed to perform fast frequency response, etc. But we can build that into the software. So again, as long as we understand the request from the aggregator or the demand response manager, we can build that into our software, and we can also send back the appropriate response from our software to say that the event has been participated in, any savings made, etc., any carbon saved at that particular point in time, as long as we've got something like an RFI to establish what information is going to be sent to us and what information is needed back.
Okay. Gosh, another one here. Hang on a second. It's a very, very long question. In fact, you could probably read it. I'll read it for you. Sure. Hi, Andy. This is from Sunsuki Amanani, and apologies again for the name pronunciation. Hi, Andy. Question on the amount of data you think enough to generate, say, demand response services. Andy said that Microgrid procures the third-party historic data plus 6-week or so commissioning period to make Schneider machine learning, presumably seasonal behavior pattern, and then goes on for a brand new microgrid site like Gibraltar. How long commissioning period would be enough to get the site up and running within the feasible margin of error to live with? I guess EV charging is a big wild card. There's a lot in that question.
That's great. I'll try and break it down into chunks. But again, thank you so much for everyone for the questions, by the way, as well. I always enjoy these questions at the end. So I'll start at the bottom there. Yes, EV charging is a big wild card. The diversity factors around who is going to plug in a car and what type of car it will be at any time of the day is a big challenge for us. And it's a nut that we're working on cracking at the moment. We have to, when we're working with the client, make certain assumptions. So this is one of the key things about the consultative discussions early doors. We have to make assumptions around the types of EV chargers that are being installed and any anticipated interface they've had with their clients, their visitors, their employees, etc., about how they think they might use vehicles. Also, for us, a way we get around the EV diversification is through a load management strategy. So we have that within our own chargers that, say, for example, you have everyone turning up to work between 7 and 9 in the morning, which is typically your on-peak time for your utility from the grid. What we can do is we can actually interface a microgrid to EV charging to say, right, we will only charge what are classed as high priority vehicles or high priority users during that on-peak window. So say, for example, the financial director turns up, they plug their car into a rapid charger, they would be classed as a priority user, and we'll make sure their vehicle is charged first. And then say after 9 o'clock, when we're on an off-peak tariff, we'll look to charge the rest of our commuter vehicles. But again, fleet management is a little simpler because you tend to have profiles around the vehicles as to when and how they're going to be used. With regard to the other questions around the amount of data being produced and commissioning a site like Gibraltar, the quickest we've ever commissioned a site is 2 to 3 weeks, and that was at a customer's request that they wanted that to be their initial sort of sign off to say, we trust the system from here, because they had a fairly static load profile. For something like Gibraltar, we would work on an asset by asset basis, because obviously it's a much more complex solution. So the nice thing about the software is it is continuously optimizing. So that indicative window I gave at the start of 4 to 6 weeks, that's just talking about our initial level of confidence. After that, the system is still optimizing. It's still looking on a daily basis and building a 24-hour in advance forecast for that site. So even if there are seasonal weather changes and we have a particularly cold winter or a particularly hot summer, our system will adapt, because we're pulling in independent third-party weather data, and we're building up, you know, a profile that's relevant to that time. So the last 4 to 6 weeks that we're constantly looking at, we can extend that if necessary. If a customer says, I want to build a load profile for the last year, we might need to look at how the software would cope with all of that data, but we could try and find a way. We find that 4 to 6 weeks gives a good optimization platform for what the site is doing in business sense or in operational sense for that particular period. And the amount of data that we produce, yes, that there is that kind of question around the amount of information we're pulling back, but it tends to be quite small packets. So when I say we're scanning the network every minute, we're just pulling back small bits of data to populate into a CSV file. We're not streaming anything in real time, and we're hosting that in a local dedicated controller. As I said earlier, most of the time it's on a dedicated network as well, because again, apart from cybersecurity and firewall issues, we don't want to fill up someone's network with data. It's a relatively small amount of information we're actually producing, and that is only sent to the cloud once every 15 minutes. So what we typically tend to use is we don't even use the host's local broadband connection. We use a 4G modem within the panel, because it's such a small amount of data. The 4G modem is actually a more secure way for us to fit with our cybersecurity profile as well. So hopefully that answers all of those questions.
That's great, Andy. Thank you. Amazingly, although we obviously lost a couple of minutes in the middle there, but timing is just coming up to 11, so they are.
Great.
I'm going to reserve the very last question for myself, if I might.
Of course.
I'm just going
to. It's your privilege, Mervyn.
Well,
yeah.
Just a quick question. It's quite an even bigger question, really. I suppose what I'd ask is, in terms of policy generally, so what do you think, if you were sort of had a wish list and said to the government, look, this is what we think needs to happen to make microgrids a much bigger part of the solution in terms overall solution, and obviously that's the big strategy thing at the moment. I mean, what do you think would help the driving microgrids forward as a much bigger? Do you think it will happen organically, or do you think there's a policy that could be implemented that would actually make this happen far faster, you know, quicker?
Yeah, again, that's a great question, Mervyn. I think at the moment we're seeing an exponential growth now in the questions and inquiries around microgrid, and particularly around battery storage as well. People are very aware of the demands being put on the grid. I think if there was any kind of conversation I could have with the government, it would be that when they have things like SALIX funding, that they really, really score highly on innovation and resilience as a key part of a carbon strategy. Because when SALIX does open, it's always a first past the post system. And you tend to find that the bids that have already been written around LED lighting, variable speed drives, etc., they're already submitted. And you see the true innovation projects that take a little bit of time to pull together, they could be transformational. They sometimes miss that window. They sometimes are at the bottom of the pile just because they've taken time to capture all of the data and build a really innovative, truly innovative business case. So I would say to the government, score things on innovation and resilience. Everyone's talking about carbon reduction, which is brilliant, or the majority of people we discuss this with, they already know they've got to reduce their carbon. Yeah. The resilience element will really stimulate the market for battery and EV as well, which would be a huge benefit. So yeah, I'd say reward innovation would be the key thing.
And I think yeah, absolutely. And I think that's the other balance, isn't it, between sometimes the very short-termism of getting in when there's a funding slot open, measured against that, you know, whatever view you take of the target, whether it's 2035, 2040, 2050, ultimately it's a lot longer than some of that short-termism that's going on in the funding mechanisms. Andy, I just really need to say a huge thank you to you for today. I think a really interesting, full of information-packed summary.
Pleasure as always.
A great hour. Thank you to everyone as well who's attended today, and apologies again for the technical issues in the middle.
Yeah, apologies from my side.
Well, don't worry. These things happen, and as I say, sod's law, gone 18 months with hardly any interruptions on any event, and then all of a sudden the first event of the session, the first event of the week. But anyway, thank you to everyone who's attended. Andy, huge vote of thanks to you. Look forward to speaking again with you soon. And yeah, thank you everyone. Thanks very much for today.
Have a great week, everyone. Thank you.
Yeah, stay safe. Bye now.